Much of the computation in MATLAB revolves around single specific cases. Certain numerical inputs are provided to a function, and it responds with a numerical output. The symbolic math toolbox expands this to include more abstract and general computations. Rather than calculating a single solution to an equation, the symbolic math toolbox allows you to input an equation and have MATLAB solve it analytically to provide the general solution. Aside from providing more theoretically useful results, this also eliminates rounding errors and other side effects of finite computational power. To designate a variable as symbolic, use the sym function. For instance, if you type in x equals 1/3, normally MATLAB will set x to be the approximate decimal representation of 1/3, which is 0.333 and so on. On the other hand, if you type in x equals sym of 1/3, then MATLAB sets x equal to precisely the fraction 1/3. It takes substantially longer to compute operations on symbolic variables, but there is guaranteed to be no rounding error, and in some cases, having an answer that is a fraction can be more useful than a long decimal. To designate a function as symbolic, use the sym_fun function. The syntax here is symfun of function, inputs. This will define a general function that takes in the given inputs and combines them according to the function to produce an output. Of course, this behavior could be duplicated by simply defining a MATLAB function that takes in those inputs and gives that output, but there is an important advantage to using a symfun. It is stored as a variable, not as a separate file, which allows you to not only call it as a function, but also use it as an input term in another function. For example, if I wanted to define a function that would take in the length, width, and height of a rectangular prism and return the volume, I could define it as follows. First, I designate the three variables to be used in the function by typing syms of L, W, and H. Then, I define the function volume equals symfun of L times W times H, comma, L, W, and H as the inputs. Now I have the function for volume. I can call this function at any time by typing volume of length, width, and height, and MATLAB will return the correct answer. The symbolic math toolbox provides numerous other functions in its libraries that allow you to solve this function, reduce its terms, or otherwise manipulate it analytically. These features of the symbolic math toolbox make complicated calculations a lot easier and can save you enormous effort that would otherwise be spent calculating indefinite integrals, solving for various variables, or otherwise working with non-numerical terms.